So thanks a lot. So I think that there's a little bit of diversity of backgrounds and experience here. So I designed this talk to be really about, to appeal, I guess, to mostly beginner to intermediate kind of level of experience, maybe intermediate level of comfort with data. So if you're trying to get a little bit more like kind of beyond Excel or like think about other things, then that's kind of what this talk is about, but I'll explain a little bit more. First, just wanted to introduce myself. So I am Cherie. I work at Digital C as a data analyst, and I am a Venture for America fellow. So Venture for America is a program that places recent graduates at startups across the country. So that's how I came to join Digital C. And at Digital C, I work on our hackathons, our Data Smart Bootcamp, which is a 10-week course that teaches people basically that are kind of coming in non-technical how to start using R, SQL, and do more data analysis. And also our Learning Studio, there's a couple of courses. There's a brochure here for you to learn about it, but it's short-term courses to help people learn more about different tools that they can use. And then data analytics consulting, do a couple of projects for nonprofit and government clients. So I'd say from this kind of experience, at Digital C, we're really working with people to kind of help them design technology-driven programs and services, and especially with some of the work that we do, or I'll move to here, especially with some of the work that we do, the Data Smart Bootcamps and the Learning Studio, I think I've learned a little bit about what people think about data science or what people are hoping to learn and get out of it and how they apply it. And I just wanted to distill some of those tips for how I think it's good to get started with data analysis into this talk. So I kind of wanted to start off with like what is data science and clear up some misconceptions or thoughts that I think people have about data science. And so I think when people encounter the words data science, they get a little bit intimidated, or they think, it's all of these things, which I pulled together a word cloud of some of the words that they put in a job description of like, okay, it's machine learning and algorithms and visualizations, and you have to learn multivariable calculus and differential equations and all of this stuff. And that's how you get more into data, and that's how you do more with data. And I think, if you want to go get a job in data science, maybe that's true, but I think that even in data science, they're saying you need all of these tools. There was an article that pulled from Career Builder data science job descriptions. What are the top tools that are listed on your different applications? And so the first one they said was R. This is out of the first 50 job descriptions they found. The first one they said was R was a tool that was listed 30 times, and then SQL 27 times, and Python 22 times. But then it went down to 38 different tools. And I don't think that there's any data scientist out there that's actively using 38 different tools every single day. But I can see how it's very intimidating to the initial learner or a person who's encountering data science to see these whole job descriptions and lists of things and think, wow, like I could never actually learn that. Like data science sounds really complicated, that's not for me. But I wanted to distill down data science to, it's not about those tools and that huge list of things you need to know. It's about this visual pyramid, and it's about moving data into upwards through the chain. And so there's like a quote that's out there that's, data is not information and information is not knowledge. I don't know if anyone's ever heard this before, but the concept I think is just like when you have data, it's just one unit of information. It's just one unit of something. It's like, okay, our nonprofit serves 800 clients per week, and we serve 50% of our overall clients in the last week of the month. So that would be information, just linking bits of data together. And then knowledge is kind of creating a theory about that data. Okay, well, a lot of our clients are actually on public assistance, and it runs out by the end of the month. And so then they use our services to supplement what they're doing, or what they're trying to buy, or like support their kids. And then it goes up to the top of the chain, which is, okay, so we have this theory, let's turn that into some kind of actionable behavior. That's wisdom. Like, we should offer more services or supplementary services at our nonprofit at the last week. That's a pretty basic example, but that's really what I see the role of data science as, is it's a business function, whether you're a nonprofit or a government or corporate entity, it's helping you to answer some kind of specific question and move your data up that pyramid into information and then knowledge and wisdom. And so that's the way that I think that it's helpful to frame data science, and not necessarily as like the whole list of tools or the whole list of different things that you need to know that a lot of people first encounter data science as. And obviously, if you want your data to turn into meaningful information and then wisdom, you need a lot of different skill sets that are diverse. That's why data scientists are kind of called the unicorns, because it's very difficult to find people who are skilled in all of these things: math, stats, programming, domain knowledge. Can't really stress that enough, because data doesn't really mean anything unless you understand the context in which it's created and it's going to be used. Communicating, this is the hard one. I mean, typically if you have someone who's super good at programming or stats or math, they're a little bit less on, how do you interpret that information to the layperson. Visualizing it, and then team players, because as a data scientist you need to understand what's going on in the rest of the organization and what's the context of the industry, and need to be able to work with everyone else who's in the organization to accomplish that. And I think that even in the data science, like professional data scientists, they don't necessarily do all of it. There's more and more specialization. So, if you are heavy on computer science skills and you have a little bit of stats knowledge, you're a data engineer, and you work with very different tools than your data scientist who is familiar with algorithms and machine learning and understanding how to ask the right questions and then how to make kind of great insights from those. And if you have mostly domain expertise, and then you add a little bit of the stat skills on it, you are probably a business analyst, operations analyst, business intelligence. You're really focused on, okay, let's translate that data that we have into some kind of insight. So I say all this to kind of frame my talk, which is to say that even if it sounds very complex, and if it sounds like there's all these different things you need to know, or that like data science is some kind of black box that you put the numbers that you have at your organization in and it comes out with something, and your data scientist is like a wizard, and data is just some magical thing. First, I actually heard this at a recent conference, so I have to quote Greg Bloom, nerds are not wizards and data is not magic. I think that there are tips and tools that everyone can use and that can be distilled to everyone so that you can bring it back without learning 30 tools to really get some context and help your organization and learn some things. And you don't need to learn 30 tools before you can get valuable insights out of your data. That's, I think, really important to understand. So with that said, my 7 tips, and I kind of see this as a process that I went through in learning how to work more with data. I'm just going to go through these and talk through what I mean for each of them, with my particular caveats of, it's not designed to be all about the tools, and it's more of a mindset. So loving your data, thinking like a data scientist, understanding where data comes from, statistical analysis, and then picking apart and knowing how to be a critical consumer of data analysis is important. And then the last steps, I think, would be where the tools really come in, or diving into a language and starting to visualize. But I think that you can get those insights about data and working with data before you even pick up tools necessarily that are more complicated. If you just work through steps 1 through 5, you'd be well above the bar for most people. So, do we have any questions at this point or anything? I don't want this to be a super formal chat, so if you have questions at any point, feel free to raise your hand and just ask. So the first point, I think, is to love your data. And what I mean by this is, so as one of the 7 points that you really needed to understand to be a data scientist, there's a part about domain expertise. And so if you don't really have a passion for what
you're going to be doing with your data and what you want to achieve with it. It's really hard to get through all the nitty-gritty of, picking up the tools or all these other things and understanding it, and also just creating meaningful insights, and you're going to miss things that other people wouldn't miss when they really understand it. And so to talk a bit about my personal story or understanding of it is my guiding question that kind of brought me into thinking about data analysis and data science was, what are the interventions that are most effective at improving people's lives? I studied economics, international development economics when I was in undergrad, and that was really the question that made me started thinking about it. And then I went to work for an internship in Bangladesh with this organization called Critical Link, and they are essentially trying to be the Uber of emergency medical calls. So just like Uber, they call it like Uber the economist's dream, because it has so much like data on supply and demand side of who's requesting rides at what price and who's picking up rides at what price. And I thought that could be a similar principle to Critical Link, where so what happens is you put into their app like a request for help if you've been injured, because they don't have like ambulance service that just comes to you in Bangladesh, and then someone who's like a volunteer emergency medical responder will come to you. And so I thought like, oh, the data could really help us to figure out, who should we be training and who should we be, who's more likely to get trained and then become a full-fledged volunteer, who's more likely to get into accidents, in what area based on like past accidents, like where should we be rolling out the program first, what are the high priority areas. And so that really got me thinking about it. And so in my head, it was like the data became lives that were saved faster and more people that were helped. And that was like the motivation for what I was trying to do. And so whenever I look at interventions or whenever I look at studies, especially in the nonprofit space, I'm thinking about like, what is the ultimate impact here? And that kind of guides the questions that I ask and the analysis that I create, because I'm really concerned about that question. And so I just thought there was like this fun comic here that's like some of the prevailing thoughts about data science. So I'll read it out. We have this awesome data on insert mouth-watering description of data. We cleaned it up and we're running sophisticated analysis on it. We see story about fascinating patterns. Isn't that cool? Booyah, that sounds like so much fun. Why are you doing it? We're not sure yet, but imagine the possibilities. This has to be valuable. And the next person like, snack. Because, a lot of organizations or like people just kind of are like, yeah, like data, like that's really cool. Let's do it because, yeah, data. And I think that's really, the wrong way to go about it is like start with your question and what do you want out of it, not the tools or necessarily. So in terms of framing questions or thinking about questions, I think the important next thing is, okay, so you have your question, but how do you ask it in data analysis, and how do you answer it? And this is where I think it's important to differentiate between like a study and an analysis, because typically I think in the research environment, if you're doing a study, it's like a linear process where you're like, okay, this is my question and I'm going to get data from X number of people and they're going to tell me this, and then I'm going to create a model for these results, and then I'm going to interpret them, and then I'm going to communicate that out. So you design everything and it's a full process, whereas when you're working with data analysis, it's kind of like, well, this is what I'd like to know, but I have to pull together all these different sources to figure it out, and I have to pull together all these different things, and I have to keep going, and the data that I want might not be there, or the kinds of people that I want to ask the question might not be there, so it's kind of an iterative process. So I like to think about data analysis, and I think most data sciences will think like this as the epicycles of analysis. This is from The Art of Data Analysis by Roger Pung, who is a pretty famous data scientist. He does the Johns Hopkins Coursera course, which is pretty popular. And it's basically, it's a little hard to read, but I will go through the questions on additional slides. But the context is that you go through each of the 5 wheels, and with each of the 5 wheels, you're asking 3 questions. What's your expectation out of this cycle of analysis? And then you collect your information and you compare it to what you expect. And then you go back and you revise your expectations and you fix the data. So the first one is, well, like, what's your question? You have a question, what does your gut tell you, and then what's of interest to people, what do you know, what does the literature say? So if you go through this and you're like, okay, well there's already been 20 papers on this, or actually, my CEO has no interest in hearing this question answered, or this is not the right question to be asking because it doesn't lead into an objective. So for example, like they were, for one of our classes, they were like, well, we're interested in understanding, our boss is interested in understanding how many surgeries are done, what's our surgical volume. And then we drilled down and realized, well, they were actually interested in understanding just how good their performance was in the hospital based on a recent merge, and that didn't really, the surgical volume question wasn't really related. It was just a proxy that wasn't really perfect for that question. So then you would revise it. And then to go through, so step 2, then you explore the data and you're assuming, okay, well this is the question that I want to answer. I kind of assume or expect that you have the data to answer that question. Then you go through and you realize, well, maybe I don't. Then you realize you have to collect different data. And you build a model, and a lot of times when you build a model, you have a hypothesis or a thought of, this is what's going to come out of this model, and this is what I think is going to be true. And if it's not, then maybe you have to find an entirely new model to fit the data and to make it work. And the purpose, I think something that's relevant here is the purpose of models is not really to fit the data or necessarily just to put something together, but it's really just to refine the question, right? Because if you come up with a model and it kind of fits, but not really, then what you've really done is figured out that you need to ask the question differently. And so at each step, you're really refining and going through and changing your thoughts as opposed to a study where you're just going straight through. And then step 4, interpreting the results, same kind of thing. If your results turn out not to make sense, or you thought that there was going to be a statistical difference in something that you were looking at, but there's not, you go back and you say, well, okay, I might have to scrap this, go back to step 1 and ask entirely different questions. And then communicating the findings. So maybe your findings, maybe at this point you share your findings or share the visuals and you're not really getting interest out of that, well then you rehash it and go back again. And then the other thing is to just, when you're moving more into data analytics, I think it's very important, and I'll just go over this briefly, but just to understand what types of questions you're trying to ask or answer. Because I think the danger of data science is when you have the information, for example, to answer a descriptive question or exploratory, or maybe even like inferential, or just relationships, and then you interpret it, or you present it in a way that other people interpret it to be causal. That's kind of where the danger is, because this is kind of where it's much more difficult, right, to explain why something happened or under what conditions it's going to be happened than just, what happened. So I won't go over this too much, but just inferential questions. Can you generalize your results to a larger population? Like if you've done an experiment or you've got data about your particular nonprofit, does that hold true for all nonprofits? Predictive questions. So if this is kind of one result that you're seeing for your patients or clients at your nonprofit, what does that mean for something else? Or what does that mean based on their demographics? If most women who come and have this outcome, is that going to hold true for all women? And then causal questions, which is what we're really interested in, but it's really hard. Just, what causes different things? And then this is kind of a nice comic for this. Another huge study found no evidence that cell phones cause cancer. What was the WHO thinking? I think they just got it backward. Take a look. Total cancer incidence, and then cell phone users increasing sharply after total cancer incidence. Just to be safe, until I see more data, I'm going to assume cancer causes cell phones. So it's like, you could show visuals to someone, they'll think, oh, well, these are causal. And there's not really any sort of mechanism through which it's happening, which is the last kind of question, like how does that work? And if you don't have any information about how it actually works or how that would happen in practice, then you've not really answered the question well. So characteristics of a good question: novel, relevant, plausible, feasible, specific. I think that it's it's so easy to say, yeah, checkbox, all of these things, but then people come up with questions that are just don't hit these points, and they don't realize that they don't hit these points, and it's just more common than you would think. I think if anyone here like works in data analysis, and then you're asked to answer some questions for other people, you would know, like, yeah, this is a familiar scene. So I think the third thing that is very important in terms of framing the questions and thinking about this is knowing where your data comes from and understanding the data generating process. And how was that data created? Who created it? What was the original purpose that it was created for? What was the sampling strategy or methodology? What kind of transformation or cleaning has been done, and what's the metadata? I think I linked a Coursera course on data collection frameworks, which I think is very valuable for this, but essentially what I'm getting at here is just if you understand typical contexts in which there can be bias, then that is a very, very helpful thing.